Hi, I'm Mike. I'm one of the contributors to the Unicity Protocol. I'd like to spend the next 5 minutes talking about why we think we have something to contribute to the world. So in the history of blockchains, from Bitcoin on, every single design is based on a shared ledger. A ledger of assets and contracts which act on those assets, and they're all in the same space, the same ledger, which is also shared amongst many participants. And this leads to limitations. There is competition for resources to get into the ledger. There's competition for storage, for execution. And this leads to congestion. It leads to a marketplace for fees or gas, as people can prioritize to get their transaction into the ledger. And if you notice, there's nothing particularly peer-to-peer about this approach. It's closer to a bank, where a user who wants to send money to another user sends a message to the bank or the ledger, and the ledger gets updated, and the recipient gets to verify by looking at the ledger that they are now the legitimate owner of that asset. But if you think about Satoshi's white paper, it says a peer-to-peer electronic cash system. And this is what we want to achieve with Unicity, and actually deliver on that vision. And this is how we do it. We get rid of the shared ledger entirely, and we replace it with individual assets which live off-chain on the internet and are self-authenticating. So I can give you an asset and you have all the information you need in order to verify that you are the legitimate owner. To achieve this, we decompose blockchain into different layers. At the top, we have consensus, which is uses proof of work, and we'll talk about why in a second. So we have consensus, we have proof aggregation. Proof aggregation is basically our invention, which is designed to verify, to prove to users that an asset has not been double spent. And then we have the off-chain execution layer. And this is where transactions happen. So at the consensus, as I said, we use proof of work for 2 reasons. One is to achieve the same trust model as Bitcoin, where I can receive an asset and I don't need to trust anyone, and I can verify by myself that I am the correct owner. And the second reason is we use actually RandomX, which is a hash function developed for Monero, and it provides fair decentralization. So miners are mining this proof of work layer, and inside the block, if they win a reward, their address gets registered. And with that address, they can mint assets off-chain. On the internet, you can just think of them as files. But this proof aggregation layer allows people to prove that they have only been minted once. And when they're transferred, they have only been transferred once, or they haven't been double spent. So how does a transaction work? I have an asset, it's off-chain, it's sitting on my device. I will update the ownership of the asset, and I will generate a proof that that asset has only been spent once, and then I will transfer that to the recipient. And in this way, the recipient can receive this file and verify that they are the correct owner of the asset. So what does this mean? Why is it good? Why is it better? Well, we have reduced blockchain to its irreducible minimum, an infrastructure to prove that assets are not being double spent. The size of this blockchain here grows at maybe a megabyte or 2 megabytes a year. But it has 3 major advantages over shared ledger blockchains. The first is that you can achieve unlimited throughput. There's no transactions here. The transaction's here. And every transaction here just generates one request, one hash value, one update. This is just a Merkle tree, which can be sharded, horizontally scaled. And so the cost of a transaction is 10 to the power of minus $8. So scale is one. Privacy is another. This transaction is only between the 2 parties. No one else in the world sees it or can learn anything about it. And so this is closer to physical cash. I give you a $10 note, you receive it, and you're able to verify that you are the owner. But it's your responsibility to verify it. And the third thing is really the user and developer experience. In order to manipulate these assets, in order to do transfers, you don't need to know anything about blockchain. This is a simple Web2 SDK that allows you to make operations in this execution layer. And so what is the downside of this approach? Well, there is no shared global state. So in this case, in a shared ledger, all the assets are together. They're in memory, and they can be composed. So you can have one contract call another contract. That's not possible in this model. But in the next session, we'll talk about how we achieve shared state by creating agents and introducing an execution environment in each asset, which allows you to conditionally control how those assets are used. And this allows us to achieve all the benefits of shared state without the downsides. Thank you.